Okay, so we've done all 5 shuffles. What did you notice? So, sorry, we did shuffles 2 through 5, and then we did it 5 more times. So we got 2 through 5 and number 10. What are some of the things you noticed when we were going through and writing the numbers down?
Well, it got random slower than our shuffle we did before.
Okay, it got random slower than the riffle shuffle, it seemed like. What are some things you noticed?
Well, there were still groups.
When?
Even on, like, the last shuffle when he shuffled the 5 times.
So even on number 10,
There were still
groups. All right. So what was the number after our first riffle shuffle? Was it 1.65?
Yeah.
Yeah.
And then it was up to like 3.
Okay. So let's see what we get here. So this is after 2 of these, whatever these kinds of shuffles are called. After 2 of these shuffles, we were at 1.15.
Yeah.
Okay, and you can still see 39 that have a difference of 1.
So there's still a lot of groups.
45.
And then this is after 3 shuffles, C1. Let's bring that down. Okay.
So no, it's 1.42.
1.47. 1.47. So but still 35 groups of 1. And so now 4 shuffles on D1. Do you think this is going to go above 1.65?
I think it'll be around 1.65.
Alright, so let's see. So 4 times through 1.71. Oh, interestingly, higher entropy, but still 32 pairs that were right next to each other versus 29. So we can say around after 4 of these, it was equal to 1 riffle shuffle.
Yeah.
So this seems like it's less efficient.
D1, E1.
And the 5th
Okay,
one.
so this is after 5 of these. Let's see if we're lower than 29 now.
Or 28.
28, 1.96. So it's interesting. We still have roughly, even after 1 riffle shuffle, we had 29. Here we have 28, but it's a little bit more. So now we're getting into some interesting stuff. We have 28 groups, and you were still seeing those groups.
Yeah.
Groups of 1, different by 1. But the entropy measure is larger. So it's interesting. So it's more subtle than just the groups of 1. And then after E, S, O, F, so this will be after 10 shuffles. Do you think we're going to be above 3 for the
Maybe.
entropy?
I don't think so.
I think we'll be like a 2.5.
You think we'll be at 2.5? Okay, let's see. Bring all those numbers in.
We have entropy.
2.7, and but we still have 18
Groups.
pairs, or cards that were originally right next to each other are still right next to each other.
Yeah.
So it seems like you can achieve randomness with this shuffle, but you have to do it a lot more.
Yeah, now I think we got lucky with our riffle shuffles yesterday, and even after 2 riffle shuffles, our entropy was above 3, and we saw in the guy's computer program that it wasn't supposed to go up that fast, so we just kind of got lucky.
7.
But here, after 10 of these shifting the cards around shuffles, after 10 of them, we're still not above entropy 3, and we still have 18 cards. So 18 times 3 is 54. So it's still roughly 1/3 of the deck hasn't been mixed up yet. Which is pretty surprising. Now, maybe that's not exactly the right way to look at it, because it's not like 1/3 of the deck remains together, but still, these cards, and you noticed them when we were reading the numbers, that there were still pairs together. In fact, if we go and look.
Like here's 22.
Oh, sorry.
It's like 22, 23, 24, and 25.
Yeah, 22, 23, 24, and 25. And then 28, 29, 30, 31 are together.
Yeah.
So it probably takes, I don't know if we did 10 more of these, maybe. But the riffle shuffle is definitely mixing the cards up more effectively than this. But this is a good experiment to do, because, again, one of the neat things about this is you can measure how mixed up something is.
Yeah.
And just from a very simple experiment, we've found that the riffle shuffle seems to be better than this shuffle. All right, good work this morning, guys.